Now, before we can answer this question about a train, we need a little bit of knowledge of physics. So we have some properties called scalars and we have some property called vectors, which some of you may already be familiar with. The scalars just have a simple number, so distance and speed, we just have a number. Now, when we use displacement and velocity, then we also include a direction in that. So if I was walking forward at a constant speed, we might say I'm walking at something like, say, 3 meters per second. But if I was to walk backwards, I would still have a speed of 3 meters per second. However, I would have a velocity of negative 3 meters per second as I'm in the opposite direction. Now, the connection between these properties here is if we want to find one of these ones below, what we're actually going to do is we're going to differentiate. So if you differentiate displacement, it gives you velocity. Similarly, if you differentiate velocity, it would give you acceleration. So I'm going to put that one. I'm putting dy by dx. Probably it's more likely to be dy by dt here or something similar to that because we're actually differentiating with respect to time with these types of questions. Similarly, if we want to work up the other way, if I know acceleration, if I integrate it, it will actually give me velocity. And if I integrate velocity, it will actually give me displacement. So those of you who are familiar with velocity time graphs, if you want to find out what the total distance or displacement is, you can actually integrate that or look at the area under the graph. Okay, returning to this question. So our first question asks us to find the velocity and hence find the time taken for the train journey. So this is quite a confusing question, so let's look at a simpler question first. So if I had something like this and I asked you to differentiate it, then you say the differential of sine is cosine of the same thing. Differential of 3t would be 3 times by the negative 2 would give me negative 6. Now this is exactly the same, it just looks a little bit more complicated. So dx by dt, when I differentiate, which is in other words the velocity from here, then the 11 I don't need to worry about, but I do need to worry about this. So the differential of t would be 1. The number at the front we can leave alone. The differential of sine is cosine of the same thing, times by the derivative of what's inside the parentheses, which is pi over 45. Now, the reason I chose this is because this actually all cancels out. So you actually end up with an expression that's quite nice. Now, the key thing about this is the train, when it's at the station, is not moving. So that tells you that the velocity is actually 0. So this is our expression for velocity, and our question says, what is the time of the train at each point? So what we can do is we can set the velocity equal to 0. And then if we can solve that question, we can find out the times the train were actually at each station. And we also know that it doesn't stop at any other point on the line. So I can divide both sides by 11. I can bring this term to the other side. So cosine of pi over 45t would equal 1. Now we can probably do this one without a calculator because we actually know when the value of cosine is equal to 1. 0 and 360, but as we're doing this question in radians, I can see the pi here, then I actually know that the answers to this would be 0, 2 pi, 4 pi, and so on. So one of these values, to make this equal to 0, if I choose t equals 0, which actually makes perfect sense. At the start of the journey, the train would obviously be at the first station. So that's what's called our trivial solution. Also, we need to make this equal to 2 pi. So if we chose t as 90, 90 over 45 would be 2, times by pi would be 2 pi. So our other value is 90. So the time taken for the journey then is just going to be 90. And if we look at the units for this question, then we find out that it's seconds, so 90 seconds. So in other words, a very short journey. Now, part B asks us to find the distance between the trains, and hence the average velocity. So the distance, we're going to go back to this formula up here. But now we also know the two values of when the train is at those stations. So we can substitute into here. So our time equals 0. X is equal to 11. T is 0 here. 0 times anything is going to be 0. So I got minus 45 over pi, sine of 0. And all this turns out to be 0, not surprisingly, because we haven't travelled anywhere yet. So at t equals 0, the distance is also 0. Now our other value, which was time equals 90, we can also plug into here. So we got 11 times by, so t this time is 90. minus, I got 90 over 45, which is 2 times by pi is 2 pi. So I got 45 over pi, sine of 2 pi. Now sine of 2 pi is actually just 0, so this term here actually just cancels. So what I have is 11 times by 90, which is 990. So as this question is meters, the distance between the two trains is 990 meters. Now the question asks us for the average velocity. So there's connections, speed, distance, times formulas. So if we divide this distance by 90 seconds, which was the actual time of the trip from the previous question, then you actually find that it's 11 meters per second. Now if you're not very good with your units, just think about what this question actually is. This one is meters, this was time, which was measured in seconds. So you can see this is meters over seconds if you're not so good by comparing units. Now part C asks us to find the acceleration 30 seconds after the train leaves the station. So we're going to use the fact that acceleration is the derivative of velocity. So we have our expression here for velocity. Now I cancelled out the 11 here earlier, so I'm going to rewrite this expression. So V is 11, 1 minus cosine pi over 45 times t. And this is the expression I'm going to differentiate. So dv by dt, which is in other words your acceleration, equals 11 times, differential of 1 is just 0, so that goes. Differential of cosine is negative sine. Now I already have a negative here as well, so that's going to make this sine of the same thing, times by the derivative of this, which is just pi over 45. So I'm going to put that in at the front of our question here. Now the question asks to find the acceleration 30 seconds into the journey, so I just need to substitute in 30 for t. So I have 30 pi over 45, just replacing t by 30, and then I should be able to work out what this is. Now 30 over 45 I recognise straight away as 2/3 actually, and 2 pi over 3 is 120 degrees, so we should also be able to work out that as well. And we can also use our calculators for this. So sine of 120 should be radical 3 over 2. And I would actually be quite happy to leave the answer like this. This would be a very exact form of this answer. So I'm going to go ahead and leave it like that. If we substitute in, this is approximately 3, this is approximately 1.7, 30, about 51. We're probably looking at about 5 over 9 or 0.55. And the unit for acceleration is meters per second squared.